We have a straight wire with a current of 4.9 amps and a magnetic field. That's at a right angle to a wire. All of the examples we're going to do are going to have the current and the direction of the magnetic field perpendicular to each other, because in that configuration you get the maximum amount of force. So we are not going to take vectors into account with this, though you could. So we have 0.15 meters of wire, so that is our length. And I'm going to use a capital L because in many fonts a capital or lowercase l looks just like a capital I. So for simplicity I'm going to use a capital L here. And the force on the wire is 0.25 newtons. And what is the strength of magnetic field? And that's B. And we have the equation. Force equals the magnetic field strength times the current times the length of the wire. So if we want to solve for the magnetic field strength, we have F divided by I times L. So we'll do 0.25 newtons divided by 4.9 amps times 0.15 meters. And quite honestly, at this case, you cannot see how newtons, amps, and meters cancel out to get Teslas, because these units are derived units. Like watts is joules per second, but you don't necessarily see that. So honestly, by this point, you just need to know what units go with which measurement. When we do the math here, and when we round to the correct two significant figures, we get that the strength of the field is 0.34 Teslas. And this is yet another unit named after a scientist. Tesla was pretty famous for his electricity work, though he was pretty insane as well, literally. Try the practice problems. Please let me know if you have questions.